equals 2. Right? You've seen this before. What would you do? Draw the graph, draw the number line, right? Let's see, we always know that in the center there's a 0. To the left we put -1, -2, -3. So we know how the number line works. Smaller to the left, 0 in the center, and to the right the numbers get bigger, right? They count up sequentially, 1, 2, 3, 4, on and on forever, both directions. And on this number line we're representing the x values, or whatever that one variable, that one letter was that we were talking about. X is the most popular one, but we could have used anything, right? To graph x equals 2, I would go to 2 and put a dot, right? And you guys have also learned how to do inequalities too. Well, I could have said x is bigger than 2, and maybe you would color and stuff like that. The idea is that in math, it's not always so simple that you just have one solution, that you just have one unknown that you get a value for. In fact, a more common scenario would be that you have two things. You have two variables or two unknown things that are somehow related to each other, maybe by constraints or something like that. Constraints like cost constraints, or how much material do you have constraints, things that would kind of put rules on the letters or on the question mark that you have in the problem or in the relationship. So we go then from a one-dimensional idea to an idea that can take on more than just one dimension. Typically in math, we'll spend most of our time in 2 dimensions, where we use an x and a y. But it can go on forever. You can have 3-dimensional ideas where you have 3 variables and you graph those, or you can have 4-dimensional, you can't really see it, but you can talk about it in theory, on and on and on. So today what I'm introducing to you is the merger of 2 variables. The idea is we're going to take this number line and merge it with another one, so that we can then talk about 2, an x and a y. So we take this idea, here's our x-axis that we just talked about, and we just add another axis to it, like that. This is called the rectangular coordinate system. And I'm abbreviating it because it's in the title, the spelling. The way it works, the default for this picture, it's like 2 number lines. So see how up here we have this red one where you have 0, 1, 2, 3, 4, -1? That's like this one right here, this horizontal one right here on the axis I created for you. So the center of this, what would it make sense for that to be where the 2 lines cross? 0, okay. So it's 0 going side to side. And then if we go to the right, we have 1, 2, on and on, right? Same thing to the left. Even though, it's to scale like always, but I'm just not writing it that way. And again, this right here defaults to being our x-axis, to talking about our x values. The other typical variable that we deal with would be the y. That's the other popular one we like to talk about. So this other axis then is going to be y. Does it make sense to you guys to have negative stuff on the bottom or on top? What would make the most sense? Bottom. Like you're thinking about sea level. This is below sea level. This is above. Negative, positive. So it works like you would expect. It's set up to make sense. So for the y stuff, the negative stuff goes down. -1, -2, -3, -4. And the positive stuff, 1, 2, 3, 4, 5, goes up. So it really is just 2 number lines crossed. And again, this one right here is going up. This is the y-axis. And of course, this point where they intersect, as far as the up-down value, as far as the y value goes, what is it at that point? What is y when they cross at the intersection of the 2 axes? 0. Yeah, it's nothing. In fact, this has a special name. Where's my little marker? This has a special name. It's called the origin. I don't like the delay on my green pin here. Origin. And yeah, it's right here where they cross. It's So that's center point. And if you were notating it, it would be the point 0, 0, where x is equal to 0, comma, y is equal to 0. I'm getting ready to talk a lot more about this right here, like right now. So don't freak out that you're putting something like that in your notes. But first I want to talk to you more about just this graph that we're looking at, this intersection of the two number lines, about how that thing works. What we say is, I told you how the picture takes on dimension. We say that we have these two things crossed, that this is a plane. It's like a sheet of paper where it's like Battleship or something, It's a plane where you're going to refer to the x and y. But that's just a vocab word I want to throw out at you. And the way we talk about our Battleship thesis is using something called ordered pairs to describe the location. So for location of a specific point, we use an ordered pair. Ordered pair meaning, you know what, by definition, we're going to know what the first number represents and what the second number represents when we refer to it. Like in, what was it, Battleship G4? Well, you go over G and up 4. You know what I mean? Like, it tells you how to walk. Did anyone in here ever play Battleship? Thank you. No one was enjoying my example. I'm sitting here thinking I need to go to the store and buy this game. Okay, so the way an ordered pair works is you always put the x value first, comma, the y value, and you put them in parentheses. And that right there actually cites, or it tells you exactly where you can find the 1 point, x, comma, y. And if you have trouble remembering, just think ABCs. Which comes first, x or y? X. X, y, okay. Guess what? If I added another axis and made it 3D, guess what I'm going to call the third one? X, Y, Z. Yeah. And guess it would come third. X, Y, Z. So it continues as you go on in mathematics. They try to use some pattern and try to keep it kind of making sense. But x, comma, y is what we use. And when I first started doing this, and sometimes when I'm feeling distracted, I still do it. When I first started dealing with ordered pairs, I would always write this to remind myself. So above any 0, comma, 0, I would put x, comma, y to remind me what's going on, to remind me which number's which. And then once you get comfortable with that, you don't have to actually write it. I guess it depends on how visual you are as a learner. I'm very visual, so I like to see it. But let's discuss plotting points using the ordered pair system. So let's plot some points. Oh, something else though before I move on. Here's some more vocab that I'm not going to go too much into, but it's just stuff in the book that you may see later in your life. This number for x, I haven't used this much, but I think in pre-calculus they use it a lot more if you take that. It's called the Abscisca or something. Abscisca. I don't even know how to say the word. See? And then this word right here is called the ordinate. The most important thing is this is the up-down. This is the vertical. And this is the side-to-side, the horizontal. That is a default thing. Unless, if you're doing some really weird graphing, I guess you could tell the reader that you were playing around. But that's the default. The x is the side-to-side, y is the up and down. Oh, actually, before I graph, I do want to add something else to our pretty picture. See how these two lines kind of make 4 divisions? It's like 4 territories on our graph. We have ways of referring to those. Basically, we call them quadrants. And the quadrants start off with 1, and it goes counterclockwise. So up here we have quadrant 1. Then you go counterclockwise, quadrant 2. Quadrant 3 and quadrant 4. We're exactly on the line. You would just say it was on that axis. So if it were laying exactly on the x, that's okay. For it to be exactly on the x line, you would just describe it as being on the x-axis. Some math classes may have you talk about the quadrants a little more, but for right now, that's enough. That's enough to get you through what I want you to know. So plotting points. Plotting points. Notice there are arrows on the end of every axis, because we are saying, hey, this does go on forever, by the way. And this center point is always 0, 0. That's always the origin. Because it's hard for me to write all the numbers in. I'll tell you guys, generally what a mathematician would request if you guys were giving graphs and you're looking at each other's work is that the first tally mark shows the scale. Or, I mean, I guess what I'm doing showing the tens is reasonable because you could count up, but a lot of times they'll say, hey, tell me the scale, I'll put in a 1 right there so I know what you're counting by. Because I could have put 2, 4, 6, 8 if I wanted. Remember that the way I draw my pictures up to me. Give tens. So let's see, let's make up some points to plot. How about 3, 4? If I said, hey guys, plot the point 3, 4. What's that mean? What's the x and what's the y? Okay, so on the x-axis, that's the x and that's the y. I'm going to go, let's see. I start here at the origin. 1, 2, 3. That's positive 3 on the x, right? And then with the y, I'm going to go positive direction for the y. 1, 2, 3, 4. Like battleship, you connect your two things and come together to that point. Do you see what I just did? So 1, 2, 3. 1, 2, 3, 4. And that's the point 3, 4. I don't have to label it again. I'm just doing it so that your notes will show it clearly. Negative 2, 1. X is what? And Y is, okay. So I'm going to say 1, 2, and then I'll go up 1, right? So with this one, the direction said 1, 2. So I go negative 2 on the X line, 1, which is right there. There's positive 1 on the Y line, and that gives me that dot right there. And a lot of times with graphs, they might even have it like on graphing paper where that way it helps you see if you're counting up how many steps easier. I don't know, you know, how familiar you guys are with that. By the way, the red point, which quadrant was it in? Yeah, quadrant 1, right? The blue point, what quadrant was it in? 2, okay. Notice stuff for me. In the first quadrant, my values will always be positive, negative, or some combination. Positive. If I'm ending up here, that means I had to have been positive this way and this way, on the X and on the Y, right? What about quadrant 2? What's always going to be negative in quadrant 2? The X, yeah. I always had to walk backwards on the X-axis and up in the Y. What about down here? X is negative. What about the Y? It's negative 2. This is negative and negative. Neat to notice. This is quadrant 3, remember. 1, 2, 3. Over here, positive on the X. What about that Y? Negative. So positive, negative. And we do talk about the X first. Again, 0, 0. They're both positive. It's on the origin. Okay. Let's graph one more just to make sure. How about, I'll use this hard green that goes super slow. How about 0, negative 5? How much do I move in the X direction? None. Okay, so I'm staying at this kind of center point. And then how much do I move in the Y direction? Down 5, negative 5. 1, 2, 3, 4. Oh man, did I just make lines everywhere? I think I amused myself by using that color, even though it writes horribly. 0, negative 5. That's what that says. Okay, so one of your objectives today, you've already learned it, was to be comfortable with the whole rectangular coordinate system, the idea of the two number lines intersected, and to be comfortable graphing. So hopefully you're okay so far. The next thing we're going to talk about is looking at equations that have both variables and discussing kind of what that relationship, when it's true, etc. And then we'll go back to the graphing idea.